Hello everyone, let's try to solve another type of question based upon network flow diagrams. In a workshop, certain machine components are stored in 7 locations named A, B, C, D, E, F and G called storage locations. These components are to be carried to location Q for further processing by a robot. Various paths connecting different locations as well as the number of machine components stored at different storage locations are shown in the diagram below. The robot can take only one of the paths given in the diagram and can only travel along the direction of the arrow. For example, the robot can travel from E to F but not from F to E. So these are the 7 storage locations that we have been given: A, B, C, D, E, F, G. These are the different 7 storage locations, and these 150, 140, 120, all these are the number of components stored at these locations. So now these components, they have to be taken to location Q from P and they are carried by a robot. It has been given to us that the robot can take only one of the paths given in the diagram and can travel only along the direction of the arrow. So this makes it very clear that the robot cannot travel in the opposite direction of an arrow. Like it has been given here that it can travel from E to F but not F to E. I hope this is understood. Now let us read further. The robot starts with a drum from location P. So he is starting from location P, follows one of the possible routes. So he will be following a possible route which satisfies all the conditions, that it has to travel along the direction of an arrow, not opposite to it. Visits all the storage locations along that route. Okay, so he is visiting all the locations along the route. Puts all the machine components at that location in the drum. So whatever number of components are there at a particular location, he'll put that into the drum he is carrying. And finally drops all the machine components at location Q. So this is where he is dumping all the components. Now the first question that we have is, how many routes can a robot take from P to Q such that it carries at most 550 machine components? So at most 550 means less than or equal to 550. So first of all, we have to take care of all the possible routes from P to Q. So we'll form a table. We'll try to put in all the possible routes from P to Q, and along with that we will also find out the total number of components that the robot puts into his drum while going through a particular route. For example, if the robot is going through the path A, B, E and then G, so he'll reach Q after that. He started from P with a drum, he comes to A, okay, because this is the direction of the arrow. He comes to A, puts these 50 components into his drum. Now he moves forward, reaches B, then he puts 120 components more into his drum. Then again he moves forward along E, he puts all the components at E into his drum. Then he again moves forward, he reaches G. Now he puts these 150 components into his drum, and finally he comes to Q with his drum and dumps all the components at Q. So this was one of the possible routes. He could have also gone through, he could have started from P, then he could have gone to C, he could have picked up all the components at C into his drum, then he would have moved forward along this direction, then he would have reached D, put all these 80 components into his drum, move forward, reach F, put all these 100 components into his drum, then reach G from this path and put these 150 components into his drum, and finally reach Q. So like this, we have to take care of all the possible routes that the robot can take for going from P to Q. So let us form a table with all the possible paths, and we'll also try to find out the number of components taken along each path. If we read the second question, what is the maximum difference between number of machine components carried by robot along the route that visits maximum storage locations and that of a route that visits minimum storage locations between P and Q? So again we are talking about number of components and the path. Third question is, what is the number of possible paths taken by the robot between P and Q such that the number of machine components carried by it is equal to 540. So again we are talking about the paths and the number of components. Fourth is, if due to oil spill between B and D, the robot cannot travel along the path B and D. So now he will not go through the path B and D. What is the maximum number of components carried out by the robots now? So again in the fourth question we are talking about number of components and paths. So yes, let us form a table, as I said, with the paths and the number of components along a path. Let's go to the next slide. So this is the diagram that was given to us. We will be taking care of all the paths and the number of components carried along a particular path. So if we look into the first case here, then we can go through this particular path A, B, E, G to reach Q. So let me write the path over here, A, B, E, G. Now let us try to add the number of components at each location. 50 plus 120, 170, 170 plus 140, 310, 310 plus 150, 460. So this comes out as 460. Now let us try to find out another possible route. He can go through this route, A, B, E, F, then G, and reach Q finally. So the path becomes A, B, E, F, G. If you add the number of components at A, B, E, F, G, 50 plus 120, 170, 170 plus 140, 310, 310 plus 100, 410, 410 plus 150 gives us 560. So this is the total number of components carried along this path. This will be second possible path. Third possible path could have been, he could have started from P, moved to A, then B, then directly to this F from B, and then to G, then Q. So another possible path becomes A, B, F, G. So let me write A, B, F, G over here. Add the number of components here, 50 plus 120, 170, 170 plus 100 is 270, 270 plus 150 becomes 420. We also know that from P, the robot can also go to C first, if not A. So first of all, we are taking care of all the paths that he can take towards this route. That means first of all, he'll go to A and then he can change his paths. We'll take care of the paths that start from C later on. So let's find out the fourth possible route. It can also go through A, B, then D, then F, then G, at last Q. So we have another route, A, B, D, F, G. A is 50, B is 120, D is 80, F is 100, G is 150. So if we add them, 50 plus 120, 170, 170 plus 80, 250, 250 plus 100, 350, 350 plus 150 becomes 500, and the path is A, B, D, F, G. Let's try to find out whether there are more possible paths from A. The robot can also go through A, B, then D, then E, then G at last. So the path becomes A, B, D, E, G. So A, B, D, E, G is another possible route. 50 plus 120, 170, 170 plus 80, 250, 250 plus 140, 390, 390 plus 150, 540. So let me write it over here. Let's try to find out another possible route. It could be A, B, D, E, then F, then G. It is possible. Yes, all the arrow directions are over here. D, E, F and G. So A, B, D, E, F and G. Add the number of components at each locations. 50, 120, 170 plus 80, 250 plus 140, 390 plus 100, 490 plus 150, 640. So this will be 640. Let us try to find out another possible route from A only. So we have already gone through A, B, E, G. We have gone through A, B, D, E, G, A, B, D, E, F, G, A, B, F, G, A, B, D, F, G. So if you properly see, we have covered all the paths that start from A. Since we have to move only in the direction of arrows, we cannot take a path opposite to the direction of the arrow. So all the paths that start from A, they have been covered. Now let us try to look into the paths that start from C. Yes, because from P the robot can also go to C first and then he can take different routes. So let's start with the paths that start from C. So this will be our 7th possible route. It can go through C first, then this A, then from A he goes to B, then to E, then G. So C, A, B, E, G is one possible path. C, A, B, E, G. Add the number of components: 70 plus 50, 120, 120 plus 120, 240, 240 plus 140, 380, 380 plus 150, 530. Next possible route can be C, A, B, E, then F, then G. So now we have C, A, B, E, F, G. In this case, the 7th one, we can see that it is going through C, A, B, E, G. In 8th one, it is going through C, A, B, E, F, G. So there is just this extra F over here. So what is the value of location F? It is 100. So we'll just add 100 to the value of the previous path. So 530 plus 100 becomes 630. This will be the number of components carried along path number 8. Now the 9th possible route could be C, then A, B, then he can directly go to F, then he can reach G. So C, A, B, F, G is another possible route. C, A, B, F, G. So add the number of components at the locations. C, which is 70 plus 50, 120, 120 plus 120, 240, 240 plus 100, 340, 340 plus 150, 490. Let's look into another possible route if there's any. He can also go through C, A, B, then D, then F, then G. So C, A, B, D, F, G is another possible route. So C, A, B, D, F, G. So if you look at route number 9, we had C, A, B, F, G. In 10th one, we have C, A, B, D, F, G. So there is just this D extra over here in the 10th route. So we'll just add the value of D to 490. What is the value of D? It is 80. So 490 plus 80 gives us 570. So in 10th route, we have gone through C, A, B, D, F, G. Let's look into the 11th route. The 11th route could have been C, A, B, then he can go to E directly, then G. So C, A, B, E, G is another possible route. B, E, G. So in the 11th route, he can go through C, A, then B, then this D, then E, then G. So the route will be C, A, B, D, E, G. So in the previous route, route number 10, we had C, A, B, D, F, G. In 11th one, we have C, A, B, D, E, G. So we just have to replace F by E. So the value of storage location F was 100. So we'll subtract 100 from 570. We are left with 470. Now we'll add the value of E. Value of E is 140. So 470 plus 140 becomes 610. Now let us try to find out another possible route. Is there a route in which he can go through all the locations? C, then A, then B, then D, then E, then F, then G. So yes, this is the route in which he is going through all the locations. It will be C, A, B, D, E, F, G. What is the sum of values of all the locations? It is 710. You can add it. Let's try to find out another possible route. The robot can also directly go through C, then D, then F, then to G. So C, D, F, G is another route having value 70 plus 80 150 plus 100 250 plus 150 400. Let's try to find out another possible route. He can go through C, D, then E, then G. We haven't gone through this route earlier, so C, D, E, G will be another possible route having value 70 plus 80 150 plus 140 290 plus 150 440. Let's try to find out another possible route. He can also go through C, D, E, F, then G. So have we gone through this route earlier? No. So C, D, E, F, G will be another possible route having value 70 plus 80 150 plus 140 290 plus 100 390 plus 150 540. So there are no more routes possible. You can check yourself. Now checking routes in this way can consume a lot of time. So what we could have done is, first of all, we can start from either A or by C. Now from A we have only one choice to go to B, so we'll go to B always. From C we have two choices, either to go to A or to D. So we can form routes starting from CA or also from CD. Then if you look at this AB case, then from B we have choice E, choice F, also choice D. So A, B, E could have been one possible route. A, B, D could have been one possible route. A, B, F could have been the initial part of the route that is possible. Similarly in this CA also we have to go to B first, because from A we only have one route and that is to B. Again from B we have three choices, E, F and also D. So that is how we can form route. Once we can go through CABE, then CABF, then CABD. So that is how we can proceed to find out the possible routes. So now we are done with all the possible routes. Let us try to solve the questions using this table. So this is the table that we have. First question is, how many routes can a robot take from P to Q such that it carries at most 550 machine components? So at most 550 means 550 or less than that. So let's see how many cases do we have. Case number 1 is there, less than 550. Then case 3, 4, 5, 7 also, 9th one. Then we have 13th one, 14th one and 15th one. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 such routes possible. Then the second question is, what is the maximum difference between number of machine components carried by robot along the route that visits maximum storage locations and that of a route that visits minimum storage locations between P and Q? So we have to focus upon maximum difference between the route that visits maximum storage locations and minimum storage locations. So which is the route that visits maximum storage locations? It is route number 12, because it is going through all the locations C, A, B, D, E, F, G. It has number of components as 710. And which is the route that goes through minimum storage locations? So we have to go through minimum 4 storage locations. We can see it in the first case, then in the third case, then also case number 13, case number 14. So there are multiple routes that go through minimum locations, but since we have to maximize the difference and we have 710 as the number of components when it is going through maximum number of locations, so this must be as minimum as possible. That means the route going through minimum locations, it must be as small as possible to maximize the difference. So in one case it is 460, it is 420 also, then in one case it is 400 and 440 as well. So to maximize the difference, we will choose the route with minimum value, the route having minimum components. So it is 400 over here, so we'll be using 400, so the maximum difference will be 310. So 310 will be the correct answer to the second question. Now let us solve the third question. What is the number of possible paths taken by the robot between P and Q such that the number of machine components carried by it is equal to 540? So now we must have components exactly equal to 540. So we have one case over here, then another case over here. There is no other route in which number of components is equal to 540. So there will be only two paths. So answer to this third question is 2. Fourth question is, if due to oil spill between B and D, the robot cannot travel along path B and D, what is the maximum number of components carried out by the robot now? So now we cannot travel along the path BD. So what we will do, from all the possible routes, let us remove the routes in which path BD was involved. That means there was a connection between B and D directly. So where do we have such paths? This is one of them, let's remove it. This is one of them, remove it. Remove this one also. Then we have BD over here, remove it. BD over here, remove it. Remove this one also. Do we have any other route in which we are going through path BD? No. So let us try to find out the route now which has the maximum number of components. So it is 460 here, 560 here, 420 here. Will not take care of these. Then we have 530, then we have 630, then 490, then forget this, 400, 440, 540. So which is the maximum of all these that I have underlined? We can see that 630 is the maximum. So 630 will be the correct answer, because in this one there is no route BD involved and the number of components is maximum. So this was a very easy question. I hope you would have solved it. We just need to find out all the possible routes and sum of the number of components. If there's any doubt, you can still ask. Thank you.